Hi guys, welcome back to the show. So we've been looking at a lot of things, guys. We looked at some exponential equations, right, that have to do with factorization and all of that. So now we're going to just close it off with some sets there, and we're also going to look at some other concepts that have to do with some exponential equations. So let's just jump right into it and see exactly what I'm talking about. Now, equations with rational exponents, as I said, remember the rational exponent will be in the form of m over n, right? That's a fraction rather of an exponent. Thus, an equation with rational exponents will then be given in the form of x to the exponent of m over n, all equal to a, right? Doesn't matter what a is. The most important thing there will be just having that exponent there as a rational exponent. Now, to solve these equations, the main thing that you need to make sure is you raise both sides of the equation to the reciprocal. Remember, we spoke about the reciprocal. The reciprocal will be whatever that was the numerator becomes the denominator, whatever that was the denominator becomes the numerator of whatever the fraction is. So in this instance, our fraction was m over n. So it means the reciprocal will be n over m, right? When you raise it, it's the same as you multiplying the exponents, right? Therefore, this and that will divide, that and that will divide. I will be left with just x is equals to a to the exponent of n over m, like that, right? So that's what I will then have there for you. Now, we have some special cases that have to do with rational exponents, right? Case one is where, where x to the exponent of m over n is equals to a, where the a value is a positive and the m value is an even number, right? A value will be this, so this is a positive, and the m value there will be the even number, right? This is a very special case, and there's going to be the next special case. What this means is the answer here is going to be plus or minus a to the exponent of n over m. Why? Because it will be more like you are square rooting on both sides, right? Or fourth rooting if it's 4. So let me just make an example of what I'm talking about here. So if I give you x to the exponent of 2 over, it doesn't matter, let me just leave it as n, is equals to 4, right? If I simplify this thing on the left hand side, it is the same as me having x to the exponent of 1 over n raised to the exponent of 2 there, right? And is equals to 4, you see. So what does this mean? If I then square root both sides, this will give me a plus or minus on the right hand side. That will give me a plus or minus because of that squared. That's really what I just mean here. Now, the opposite of this does not give us a solution. If m, right, is either, or the m or the n is an even number, it doesn't matter, but the a value is a negative, there is definitely no solution there. What do I mean? If I give you 2 to the exponent of minus 3 over 2 is equals to, right, negative x, like this, right? So you can already see that there is no way that I will have negative x to be changed to have a base of 2 and a base of 2 that is positive in order to do anything there, right? But let me make it in terms of x. So if I give you x to the exponent of negative 3 over 2 is equals to minus 4. There's definitely no way that I will then deal with this in terms of getting a solution. Why? Because of that negative there. I can't change what is on the left-hand side and make it to have a positive there. But let's just look at examples, exactly what do we mean. So remember, you raise this to the reciprocal of the rational exponent. So it's going to be x to the exponent of 3 over 5 times 5 over 3, which is equals to 2 to the exponent of 3. I will just change the 8 so that it's easier to simplify, raised to 5 over 3. And this will give me x is equals to, remember the m value is the one at the top, is not an even number, right? So it's not going to be plus or minus. So the 3 and the 3 will divide. I will be left with 2 to the exponent of 5, and then my x will be equals to 32, and that will be the answer there. And then if I have the exponent now as a negative, it doesn't really make a difference, especially if the value on the right hand side is a positive. So this will be x minus 5 over 2 times minus 2 over 5, which is equals to, I will also change 32 to 2 to the exponent of 5, and this will be raised to minus 2 over 5 rather. Minus 2 over 5. Minus 2 over 5, and this will be x is equals to the 5 and the 5. I will be left with the 2 to the exponent of minus 2, then x is equals to 1 over 4, and that will be my answer there. Now, a special case, right? This is the special case I was talking about. Immediately you see this, you know that this cannot be changed to have a negative, a positive rather, because it's a negative. So here you will just say no solution. And why is that the case? Remember my special case. When x to the exponent of m over n is equals to a, where a is a negative and m or n is even, it doesn't matter which one is even, there will not be a solution there if you are trying to solve that, right? So make sure you do understand that concept there. So here you're simply just going to say no solution. Also, even with this one, there will not be a solution here. Why? Because of this negative that I have here. But let's just try and see if we will be able to solve this. Maybe if we just try it, right? So that people can see what I'm talking about. Equals to, this is going to be negative. But now, I can't say this is negative 3 to the exponent of 3 like that, right? Oh, actually I can. Why? Because 3 to the exponent of 3 is 27, which will give me what I have there. And then I will need to multiply the whole thing, right? The whole thing by negative 2 over 3. But then how do you do that? Because there's a negative there, you see. So this will definitely be x equal to. But what I have here, I can't distribute the negative to that negative there. There is no way I'm going to do that. I also can't, this I can distribute to this exponent, but I can't distribute that negative there. So it will therefore be a concept of a no solution as well, right? You can just leave it as no solution. Now, the last example now, which involves the concept of rational exponents, will then be, what do? You change the radical to be in the form of an exponential form. So this will be the same as 9 to the exponent of x squared plus x, right? And then this will all be raised to the exponent of 1 over 3 like this. And this will be equals to 9 to the exponent of 2x. And then you can then simplify this, 9 to the exponent of 1 over 3 x squared plus 1 over 3x equal to 9 to the exponent of 2x. Why am I not changing these bases? Because already 81 gives me the base of 9. So you can already see that my bases are the same. I have 1 power, I equate my exponent. So it is 1 over 3 x squared plus 1 over 3 x equals to 2x. And then you can then start simplifying from there, right? You can just start by taking out x as a common factor or dividing everything by x, and then you solve it. So quickly, just to show you what I mean, this is going to be x into 1 over 3x plus 1 over 3 equal to 2x, and then I will have 1 over 3x plus 1 over 3 equals to 2, because I divide both sides by x, and then it will be 1 over 3x equal to 2 minus 1 over 3. And then from there, I know you can then press your calculator and simplify this. Now, so far, guys, what I want you to please go back and look at is the concept of your laws and definitions of the exponents. You need to make sure you make them rock solid, and then also go and look at solving exponential equations by making sure that the variable term and the constant have the same basis, and then you equate the exponents, because that's really the main thing that you need to do. Guys, I hope you enjoyed this lesson as much as I did. Exponents, I know, is a bit of a challenge for you guys, but I hope you've been following and you understood everything that you've done. If not, just go back to the notes that you made and revisit them, and also consult your textbooks and everything that can give you some knowledge in terms of understanding exponents better. From me, the Maths Doctor, remember, mathematics is food for the soul. Until next time.